Hello class, so ito na yung ating second part ng ating module 1 which is the unit 2. So let us proceed sa ating topic which is yung moment of a force. So yung pag-uusapan natin is about moment. So let us define it. So the moment of a force about a point is the product of the magnitude of the force by the perpendicular distance from the point to the line of action of the force. So ibig sabihin yung moment daw is yung product ng magnitude ng force by the perpendicular distance from the point of the line of action. So example, ito yung example natin. Example of the concept of moment. If we have a pipe wrench and we have a pipe, and kapag hinahawakan natin to, so nag-exert tayo ng force and it tends to rotate at this point, no? So the moment of a force about a point, yung magiging point natin is ito mismong pipe, and using the pipe wrench, magkakaroon tayo ng force F. So yung moment na kinikreate niya is through the force F and the distance. So, ibig sabihin yung moment is yung product ng magnitude ng force at yung perpendicular distance from the point of the line of action ng ating force. So meron tayong moment arm. So the perpendicular distance from the point to the line of action of the force. So yung moment arm natin is yung perpendicular distance from the point of line of action. So ito yung line of action natin to the line of action of the force. So yung moment arm natin is yun always perpendicular siya dito sa ating force. So always remember that, no? So the magnitude of the moment of a force F about a center O is expressed by M. Moment about the center O is equal to force times distance. So pinakasimple, moment is equal to force times distance. So example itong figure natin, if you have force at a distance from the A, so ito yung perpendicular distance natin or yung moment arm natin which is yung D. So moment at A na effect ng force, so that will be moment at A is equal to the force times the perpendicular distance to the point A. So M is equal to force times distance. So always yun lang yung kailangan nating i-remember sa moment. So moment is always equal to force times distance. And yung distance natin is always perpendicular sa ating force, 90 degrees, okay? So in some two-dimensional and many of the three-dimensional problems, it is convenient to use a vector approach for moment calculations. The moment of F about point O may be represented by the cross product expression MO is equal to R times the force, where yung R natin is yung any position of vector extending from the moment center to any point on the line of the force. So example itong sa figure natin, so pwede nating i-represent daw yung pag-compute natin ng moment using vectors, no? Where yung moment at O is equal to R times F kapag vector yung ginagamit natin. Okay? So, let us proceed. So, meron tayong tinatawag na principle of moments. So, we have the Varignon's theorem. Sabi niya dito, the principle of moment states that the moment of a force about any point is equal to the sum of the moments of the components of the force about the same point. So, yung sa first part nating module, di ba, we have learned kung paano kunin yung components ng isang force. Example, meron tayong force F. Nalaman natin kung paano kunin yung F of Y tsaka F of X, which is yung component ng force. And sabi sa Varignon's theorem, na yung moment daw na kinikreate ng ating force about any point, example dito sa ating figure, yung moment na kinikreate ng force F about O is the same nung sum nung moment nung force na kinikreate nung kanyang components. So, f of y, yung component ng f of y ay yung moment ng f of y at yung moment ng f of x, kapag pinagsama natin sila, is equal din siya sa moment ng mismong force na i-create about O. Okay? So sabi niya, for coplanar forces, the principle of moments can be used by resolving the force into its rectangular components and then determine the moment using a scalar analysis. So yung scalar analysis or scalar method yung gagamitin natin dito. So in computing moments in coplanar force system, the scalar method is preferred. So scalar method is preferred kaysa dun sa vector method. Okay? So ito yung pinaka-principle ng ating Varignon's theorem, na yung moment ng force about O is equal to yung summation ng moment natin ng components. So f of x, so yung moment natin, sabi natin moment is equal to force times distance. So meron tayong force, so yung perpendicular distance niya is yung x, diba? Dito sa may O. So ibig sabihin, f of y times yung perpendicular distance, which is yung x. And sabi niya, minus x times the f of y. So ito yung force natin, f of y, multiply yung perpendicular distance at O. So yun yung y natin. So bakit minus yun? So yung pag nag-ano tayo ng moment, nagsusolve tayo ng moment, so always yung direction lang natin kasi sa ating moment is meron tayong clockwise direction and counterclockwise direction. So sabi niya rito, positive is yung clockwise direction. So always remember class, pag moment, clockwise direction is positive and counterclockwise direction is negative. So kaya yung direction nito, di ba? Direction ng f of x, magmo-moment tayo dito sa point O. So kapag magmo-moment tayo, it is positive. And itong f of y naman, kapag imo-moment natin, counterclockwise na siya, di ba? So magiging negative. Okay? So let us proceed. So ito yun, yung sign convention. So para maging consistent tayo, when dealing with moments, it is important to apply a consistent sign convention of the direction of the moment. So dalawa lang naman yung direction natin, so counterclockwise or clockwise. So always remember, clockwise is positive and counterclockwise is negative. So yung units na gagamitin natin dito is SI units or US units. So kapag SI, ang ginagamit natin is yung Newton and yung distance natin meter. Diba sabi natin, moment is equal to force times distance. So yung unit ng force natin, that is in Newton, and yung distance natin is in meters. Okay? So yung unit ng moment, that will be Newton meter. And kapag sa US is that will be pound feet or pound inches. Okay? Or kilo pound feet or kilonewton meter. So yun yung unit ng ating moment. So example na tayo. So first example, if the moment of F about C is 750 pound feet, find its moment about D. Okay? So this is a coplanar system o coplanar forces. So sabi niya dito, if moment of F about C is 750 pounds, hanapin natin kung ano yun naman yung moment niya about D. Okay? So meron tayong force F dito. So di ba we have learned dun sa last module natin to compute kung yung components niya. So meron tayong magkakaroon tayo ng components dito and x components dito. So y component and then x component. So sabi natin sa Varignon's theorem, yung moment ng force is equal to dun sa moment nung kanyang summation moment nung kanyang components. Okay? So tawagin natin tong f of y and this will be f of x. So given natin is yung moment of force about C. So yung moment of force daw about C is 750 pounds. Ngayon, hanapin naman natin kung ano yung moment niya about D. Okay? So first na step natin is kunin natin kung ilan ba yung force F, no? Kung ano yung magnitude ng ating force F. Okay? So sabi natin sa principle ng Varignon's theorem is yung moment ng force about C is equal siya dun sa moment din nung summation moment nung kanyang components. So yung kanyang components, that will be moment ng f of x about C plus moment ng f of y about C. Okay? So ito yung pinaka-principle ng ating principle of moments or Varignon's theorem. So given yung moment ng force natin about C, so that will be 750 pounds feet is equal to, so yung moment ng f of x about C. So hindi natin mai-rotate yung ating f of x kasi nandun siya mismo sa line of action. Yung line of action ng force is nandun mismo yung point natin. So always remember class, hindi natin to maro-rotate kasi kung titingnan nyo yung direction ng force natin is nakadirect siya kung saan tayo magmo-moment. So, ibig sabihin hindi natin ito may moment dun sa C, sa point C. Yung f of x natin is magiging 0. Okay? 0 kasi wala tayong perpendicular distance. Yung direction ng force wala tayong perpendicular distance kasi kung saan yung line of action ng force, dun din yung nakatutok dun sa ating point C. So 0 yung moment ng f of x natin. Okay? So plus yung moment ng f of y about point C. So meron tayong f of y, that will be f of y times yung perpendicular distance or yung moment arm natin. So ito yung force Fy natin and meron tayong distance. So may moment natin siya, di ba? Kasi meron tayong perpendicular distance dito. So ilan yung sukat natin times distance? So 1 inch or 1 feet yung equivalent ng isang square. So ilan yan? So 1, 2, 3, 4, 5. So, i-multiply natin ng 5. So, yung moment natin, so makukuha na natin yung value ng f of y. So, yung value ng f of y natin, that will be f of y is equal to 750 over 5. Or is equal to 150 pounds. So, meron na yung value ng f of y natin. Ngayon, makukuha na natin yung value ng ating force F. So, kapag nakuha na natin yung value ng force F, magmo-moment na tayo sa D. Makukuha na natin kung ano yung moment ng force sa D. Okay? So, to get the value of F, so, paano natin kukunin yung value ng F? So, that will be, kunin natin yung slope ng ating force. So, yung slope ng ating force is 1, 2, ilang square siya? 1, 2, 3, 4. And yung sa y natin, 1, 2, 3. So, yung slope natin, that will be, yung force, yung slope natin, that will be 4 and 3. Okay? So, kunin natin yung ating hypotenuse. So, that will be 5. Okay? So, para siyang 3, 4, 5 na triangle. Always, pwede nyong i-check ito, no? 3 squared plus 4 squared, then square root nyo, ang lalabas dyan is 5. So, para makuha natin yung force F, So, Fy yung gamit natin. So, that will be Fy yung gamit natin, di ba? Fy, dito yung f of x. So, Fy yung gamit natin. So, i-multiply natin siya ng 3 over 5. Okay? So, makukuha na natin yung force F natin. So, that will be yung Fy natin, di ba? Para makuha natin yung Fy is yung force F is i-multiply natin siya ng 3 over 5. Di ba? So, F of Y is equal to 3 over 5 multiplied by yung force F natin. Okay? So, meron na tayong value ng F of Y. So, that will be F of Y natin is 150 pounds is equal to 3 over 5 multiplied by the force F. So, makukuha na natin yung force F natin, which is compute for the force F. So, that will be 250 pounds. So, for f of x, makukuha na natin yung f of x natin. That will be f of x is equal to 4 over 5 naman. So, that will be 4 over 5 times yung force F natin. That will be 250 pounds. So, yung f of x natin is equal to 200 pounds. So, ngayon, meron na tayong dalawang force, which is yung f of y and f of x. So, sabi natin sa Varignon's theorem is yung component nito is the same yung moment ng force F at yung summation ng component niya about D. So, yung magiging equation natin, that will be moment of force about D is equal to yung summation ng ating components, x and y components. That will be the moment of f of x about D plus the moment of f of y about D. So, yung moment of force f about D is equal to, so f of x, ano yung value ng f of x natin? That will be 200 pounds. So, kailangan clockwise positive tayo dito. So, 200 pounds. So, f of x, ito yung f of x natin. I-moment natin siya sa point ng D. So, ilan yung distance niya? That will be 1, 2, 3. And clockwise siya, di ba? Clockwise siya. So, dito yung direction natin papuntang D. I-moment natin yung f of x papuntang D. That will be clockwise. So, positive. Tama lang, positive. And ilan yung perpendicular distance niya? So, 3 box yun. So, that will be 3 feet. So, multiply natin ng 3. Okay? Plus, yung moment ng ating f of y. So, i-moment natin sa point D. So, counterclockwise siya. So, dapat negative ito. So, that will be negative f of y. Ano yung f of y natin? That will be 150 pounds. 150 pounds. Times. So, ilang box yun? Only 1. So, that will be 1 feet. Okay? So, compute for the moment of the force about D. So, moment of force about D is equal to 450 pounds per feet. Okay? Pounds feet pala, hindi per feet yan. Okay? Kasi moment. So, let us proceed for the next example. So, sabi niya dito, in the figure, find the y-coordinate of a point A so that the 361 pound force will have a clockwise moment of 400 pound-feet about point O. Also, determine the y-intercept of the action line of the force. So, we have a force here, which is yung 361 pounds. So, sabi niya, yung hinahanap natin is find the y-coordinate point of point A. So, kailangan hanapin natin tong coordinate nitong YA. Okay? So, hindi natin alam. So, that the force will have a clockwise moment of 400 pound-feet. So, kailangan yung moment nitong force about dito sa O is equal to 400 feet clockwise. So, yung moment natin ng force about O is equal to 400 pound feet clockwise. Okay? So, hanapin natin yung YA, yung coordinate nung Y of point A. So, paano natin kukunin yon? So, sabi natin dun sa Vrignon's theorem is yung moment nitong F is yung moment ng kanyang component, yung summation ng kanyang component is equal to yung moment dun ng ating force. So, kunin natin yung component niya. So, meron tayong y component tsaka x component. So, this will be Fy and this will be Fx. So, yung moment at O natin, sabi natin, yung moment ng force at O is equal siya doon sa yung summation ng moment ng kanyang components doon sa O. So, clockwise positive dapat. So, this is clockwise. So, yung moment natin yung f of x. So, that will be yung moment ng ating f of x about O plus yung moment ng ating f of y about O. So, that is equal to, ano yung moment ng ating f of x? That will be yung f of x times the distance, which is yung YA natin. Okay? Plus, yung moment ng ating f of y. So, that will be f of y times yung perpendicular distance or yung moment arm niya. That will be 2 feet. So, 2 feet. So, ngayon, yung given yung ating moment ng force O, ng force at point O, that will be 400 pounds. This will be 400 pound-feet. So, that will be, and given yung ating force, which is yung 361 pounds. So, paano natin makukuha yung f of x? So, yung magiging f of x natin is equal to, kunin natin yung slope. So, that will be 3 over 2. 2. So, kunin natin yung hypotenuse pala ng ating triangle. So, that will be 3 squared plus 2 squared. So, this will be square root of 13. Okay? So, para makuha natin yung f of x, so that will be f of x is equal to 3 over square root of 13. Tama ba? Multiplied by 361. Okay? And yung f of y natin, that will be equal to 2 over square root of 13 times 361. Okay? So, makukuha na natin yung YA natin or yung Y coordinate at point A. So, that will be 400 pound-feet is equal to f of x. That will be 3 over square root of 13 times 361 times YA. Okay? Plus, yung f of y natin, that will be 2 over square root of 13 times 361 times 2 feet. Okay? So, solve na natin yung YA. So, pwede natin i-direct na shift solve ito sa ating calculator. If you are using 991ES Plus or any calculator na kayang mag shift solve. Okay? So, that will be YA is equal to 2.67 feet. Okay? So, yung YA pala natin is equal to 2.67 feet. Okay? Ito yung magiging sagot natin. So ngayon naman kunin natin yung y-intercept of the action line of the force F. Okay? So determine the y-intercept of the action line of the force. Ngayon kunin naman natin yung y-intercept ng action line ng force natin. So ito yung force natin, di ba? So yung action line niya is ito, di ba? So kapag diniretso natin yan, diniretso natin itong ating force dito. Okay? Diniretso natin yan dito. So ito yung magiging y-intercept niya mismo dito sa ating y-axis. So hanapin natin yung y-intercept. So yung y-intercept niya is ito, di ba? Kapag diniretso natin itong force, i-intersect niya yung y, kaya tinawag na y-intercept. So hahanapin natin to, which is yung y. So yung distance nitong ating from the y-intercept hanggang dito sa ating sentro. So paano natin hahanapin yan? So magkakaroon tayo dito ng x and y component. So parang minove lang natin yung ating force, di ba? So nandito na yung ating f of y and nandito na rin yung ating f of x. So same pa rin yung moment at ng force natin, yung moment ng force natin at O is equal to 400 pound-feet. So para makuha natin yung f of y and yung iy natin, so yung Varignon's theorem ulit, yung summation ng yung moment force at point O natin is equal to summation ng kanyang moment ng component, di ba? So moment ng f of x at O at yung moment ulit ng f of y at O. Okay? So always dapat yung sign convention natin clockwise positive. Okay, no? So positive. So substitute natin, that will be 400 pound-feet is equal to, so yung moment ng x natin, ng f of x natin about O, so that will be f of x. So positive siya, no, kasi mag-rotate siya pag ganito, no, pag ganun ang rotation niya. So that will be f of x times yung iy natin, or yun yung y-intercept natin. So that will be iy plus yung moment ng f of y natin. Okay, itong f of y natin, hindi natin siya may moment dito sa ating point O, kasi kung saan yung line of action ng ating f of y is may intersect niya yung point kung saan tayo magmo-moment. So magiging 0 siya. Wala tayong perpendicular distance dun sa ating force. Kaya yung moment ng f of y at point O natin, that will be 0. Okay? So ngayon, given yung moment ng force at O, and meron tayong f of x. So para makuha natin yung f of x, sabi natin kanina, this is square root of 13. So yung f of x natin is equal to 3 over square root of 13 times ilan yung force natin dito, that will be 361 pounds. So substitute na lang natin, so that will be 400 pound-feet is equal to f of x, that will be 3 over square root of 13 times 361 times iy. So pwede na natin itong diretso sa calculator. Shift solve na lang natin. So iy is equal to 1.33 feet. So yung 1.33 feet natin, that is above O. Okay? So ito pala yung 1.33 feet natin. Okay? So this will be our answer. Okay, next example tayo. So in the rocket arm shown, the moment of F about O balances that of P about O. So find F. So we have a rocket arm. So ito yung rocket arm natin. So sabi niya rito, the moment of F about O. So binabalance niya yung force ng P or yung moment ng P about O. So para maging balance yung rocket arm natin, so dapat yung moment ng force at O is plus yung moment ng P at O is equal to 0. So in order to balance yung ating rocket arm, dapat yung summation ng moment nitong F at yung moment nitong P about O is equal to 0. Ngayon, hanapin natin yung F para maging balance sila. Okay? So, yung given natin, that will be moment of F about O plus moment of P about O is equal to 0. So, sabi natin sa Brignon's theorem, yung moment ng ating force is equal din siya dun sa summation ng moment ng kanyang component. Di ba? So, yung moment ng ating force O is equal to yung moment ng ating component. So, that will be equal to yung moment ng ating component. So, ano yung component ng ating F? So, magkakaroon tayo ng force dito. So, kunin natin yung component niya. So, this will be F of Y and this will be F of X. Okay? And then, meron tayong component dito din sa force P. So, magkakaroon tayo ng force dito. Force and we will be having a force here. So, let's call this P. So, let's call this PX. And this will be PY. Okay? So, kunin natin yung component ng both forces natin. So, sabi natin sa Brignon's theorem is yung moment ng F about O is equal din siya dun sa ating moment ng summation ng components niya. No? F of X times about O and F of Y about O. Okay? So, yung moment ng force about O is equal to yung moment ng kanyang components. So, that will be moment ng ating F of X at O plus moment ng ating F of Y at O. Okay? Plus, so yung sa P naman, so yung moment ng ating PX and yung moment ng ating PY is equal to yung moment ng ating force P about O. So, that will be yung moment ng ating PX about O plus moment ng ating PY about O. So, dapat equal to 0 ito. And class, don't forget yung ating sign convention. Kapag clockwise yung moment natin, that will be positive. And counterclockwise, that will be negative. Okay? So, first, para makuha natin yung force F, so kunin muna natin yung ating F of X and F of Y. So kunin muna natin yung slope niya. So yung slope natin is given na, so that will be 2 and 1. So kunin natin yung hypotenuse niya, so that will be 2 squared plus 1 squared. So square root natin yan, so that will be equal to square root of 5. And then here, given din yung slope niya, pero mukhang mas okay dahil naka-incline siya. Kunin na lang natin yung angle nila. Okay? Para makuha natin yung value ng PX and yung value ng PY. Okay? So, mas maganda kapag ganito yung instances, kunin natin yung value ng kanilang angle. So, kunin natin yung angle na mabubuo ng 4 and 3. So, kung paano natin makukuha yan? So, that will be shift tan, inverse tan. So, tan. So, let's call this Parehas kasi sila ng slope dito. So, kunin natin, this is angle theta. And ito, angle theta rin to. Okay? So, yung buong angle nito, so, diretso lang natin yan. So, ito yung px natin. Hanggang dito. So, yung buong angle nito, hanggang dito. So, that will be 2 theta. Okay? So, same sila ng slope, 4 and 3, 4 and 3. So, kunin natin yung angle na mabubuo nila. So, that will be in tan theta is equal to opposite. So, that will be 3 over adjacent. That will be 4. Okay? So, theta natin is equal to inverse tan 3 over 4. Okay? So, yung theta natin, that will be equal to 36.87 degrees. Okay? 36.87 degrees. Therefore, yung 2 theta natin is equal to, so 36.87 times 2, that will be 73.74 degrees. Okay? So, pwede nating substitute. So, ano yung value ng f of x natin? So, kunin muna natin yung mga value ng f of x, f of y, py, and p of x. Okay? So, yung force f natin is hindi given kasi yun yung required natin. Yun yung hinahanap natin. So, para makuha natin yung f of x, so f of x is equal to, yung slope niya, that will be 2 over square root of 5 multiplied by f. Okay? And then, yung f of y natin, that will be equal to 1 over square root of 5 times yung force f natin. And then, yung px naman natin, that will be px is equal to, so yung gagamitin natin is yung angle 2 theta natin. Okay? So, px, so sabi natin kapag px, that will be cosine. Okay? That will be cosine. Sa pag x-axis, cosine, ano? So, that will be yung value ng p natin, that is 250 pounds. So, cosine 73.74 degrees. And yung py natin, that is sine, so that will be 250 pounds cosine 73.74 degrees. Okay? And then, meron na tayong px and py. Meron din tayong f of x in terms of f and f of y in terms of f din. So, kunin na natin yung ating mag-moment na tayo. Okay? Okay, ayan. So, i-substitute na natin. So, mag-moment na tayo. So, moment of f of x about O. So, ito yung f of x natin. I-moment natin about O. So, ito yung O natin, di ba? So, f of x about O. So, that will be counterclockwise siya, no? So, dapat negative, no? Kasi ito yung direction ng ating f of x. And i-moment natin siya dito. So, mag-rotate siya papunta doon. So, kailangan magiging negative siya, no? So, wag natin kalimutan yung ating sign convention. Clockwise positive, counterclockwise negative. Okay? Positive yan. And negative dito. Okay? So, magiging negative times yung f of x natin, which is 2 over square root of 5 times f multiplied yung distance natin, which is yung 6. That will be 6 inches plus yung moment ng f of y natin. So, take note, yung f of y na naman natin is yung line of action niya is naka-point dun sa point ng O natin. So, hindi natin siya maro-rotate, no? Kasi wala siyang perpendicular distance or wala siyang moment arm. Okay? So, yung f of y natin magiging 0. Okay? And then, doon naman tayo sa p moment nung p. So, that will be yung moment nung px about o. So, yung px natin, so, ganun din class, yung line of action ng px natin is nandun sa point O. Okay? So, hindi siya mag-rotate ulit. Kaya yung moment of px natin magiging 0 ulit. So, that will be plus 0 ulit. And then, plus yung moment naman ng py natin, ayun, mag-rotate siya kasi meron tayong perpendicular distance. So, yung py natin, that will be 250 sine 73.74 degrees multiplied yung moment arm natin, which is 5 inches. Okay? So, ngayon, makukuha na natin yung magnitude ng ating force F. Okay? So, equal to 0 yan. No? That is equal to 0. So, pwede natin idiretso na lang ito sa ating calculator. So, solving for F, it will give us 223.61 pounds. Okay? So, this will be our final answer. Ito na yung magiging value ng force F natin in order to balance yung ating rocket arm. Okay? So, we will end this sa ating so, we will stop sa last na example na ito. So, I will be discussing sa ating next na Google Meet yung ating Module 2 and ating